morning, everybody. I'm super excited to welcome Jeff Winter, a major expert in Industry 4.0. Jeff, welcome.
Thanks for having me here.
I've been a huge follower of your, LinkedIn profile and YouTube and watching these videos. So I'm glad that we finally connected and you're going to take the time. But so that I don't butcher your introduction, I would love to have you introduce yourself a little bit, and then I'll cover a little more detail later on also.
Sure. So my name is Jeff Winter, and I am Vice President of Business Strategy for Critical Manufacturing, which is an MES software company in the era of Industry 4.0. And it's basically my job to help grow the company and kind of provide the strategy for how to get there. That's my daytime job. But my nighttime job, which is how most people know me, is as this Industry 4.0 influencer and thought leader, speaking all around the world, making posts on LinkedIn, writing articles, helping to kind of educate and advance the industry.
That's awesome. So I don't typically prepare for, podcasts, but this time I did because you have so much content and so much depth on every area. So it may look a little bit scripted for our audience because I generally go with the flow. But here I'm going to actually try to stick to the question that I prepared for you so that I don't go outside my capabilities of asking something that may not be relevant. So first of all, I would love to have you take a minute or two, or as long as you'd like, explain what is this Industry 4.0?
So Industry 4.0 is the nickname or the moniker given to the fourth industrial revolution. And it's based on the idea that we've had three major industrial revolutions so far. The first one taking place in the late 1700s, taking advantage of steam power, and we mechanized the world. The second industrial revolution really took place in the late 1800s and early 1900s, where we invented the combustion engine. We discovered electricity and allowed us to kind of start electrifying the world and automating the world at a basic level. Then the third industrial revolution really kind of came about because of the PLC, the internet, and the computer, allowing us to digitize and automate the world. Now we're in this new era that was coined Industry 4.0 really as part of the German high-tech strategy. It was famously introduced to the world in Germany as part of the Hanover Fair in 2011. And the idea has taken hold all around the world. Unfortunately, there's like two ways of looking at it. Some people view it as a description of the era, meaning the time that we're living in right now. And other people view it as this end goal of what's possible based off of all the technology that's out there today. And I would argue it doesn't really matter what your definition is, just come up with one that works for your company so you guys can take advantage of all these technologies out there collectively to transform what you do during this era.
So when we talk about 4.0 versus 3.0, there's shifts that are happening, right? These are major shifts. So from a mindset perspective, when you think about as a leadership team, if I'm making our organization, taking our organization through a transition, what are the, categories that I need to think about from a culture perspective, from a structure perspective? Can you sort of get into the details of that?
So the hardest part of any transformation, but especially digital transformation, isn't the technology. It's the people, because you can buy the software, you can deploy the sensors, but you can't buy mindsets. And that is where the real work comes in. So the most critical kind of cultural change starts at the top. The leaders must see digital transformation not as an IT project. They must see Industry 4.0 not limited in its scope, but as a business evolution that changes and changes how value is created, how value is delivered, and how value is measured. That's where you need to start. The leadership level and understanding it's a transformation in what you do and how you do it. This means moving from proving technology works to proving technology moves the business. And for the workforce, it's about embracing continuous learning and cross-disciplinary thinking. And in Industry 4.0, your job isn't to run a machine, it's to run a process that's connected, data-driven, and constantly improving. And, comfort with this, I view it as never something you should have, because change is all that you're going to be doing. And one of the bigger changes that occurs specifically for Industry 4.0 is bridging IT and OT. And this is about, not forcing one group to just work with the other, but to have a shared language. It's about creating a way of working together, bringing data governance, bringing security, and bringing scalability across both teams. OT brings kind of the process knowledge, the safety, and the operational realities. But without trust and collaboration, you don't get transformation. And IT brings with it kind of all the different ways of applying and utilizing technology, especially as a platform to help these processes. But without collaboration, you get turf wars and just maybe better dashboards. So here's kind of how I've seen this gap close, and kind of three areas that I would give advice on is kind of the core around Industry 4.0. First is shared goals across the teams. You need to have your IT and your OT teams be tied to the same business outcomes, not just their departmental KPIs. The second is you need to have embedded teams where IT and OT work side by side on the plant floor and in the front office, not in just kind of two completely separate different areas. And the third is what I like to call translators, people who understand enough of both worlds to kind of turn the tech speak into business impact. Because Industry 4.0, it's about technology. This revolution in the industry was driven because of new technologies that came out. But you're not going to do anything unless you rewire how your organization thinks, how it decides, and how it acts. And the ones that win don't just install new tools, they create a new culture because of the tools.
So I want to go back to this two acronym. A lot of our audiences would be familiar with IT, but I'd love to have you take a few minutes to explain what is an OT, what is typically an OT from a functional perspective in a manufacturing organization, and then, the overlaps that you're saying is necessary, or maybe alignment that is necessary. Explain that, maybe, some examples. That'll be great.
Sure. I mean, everyone knows IT, and doesn't matter what industry you're in. You usually think of the ones that set up your company computers, your cell phones, all the programs that you use and as an employee. They're the ones that typically help determine technology to meet business needs, manage the technology to meet business needs. And they're typically working with kind of the business side of things, your finance, your HR, and it can be kind of how operations is run. OT has always kind of been separate, and most of the time it was traditionally thought of as the stuff controlling your production. So your PLCs on the actual equipment telling the machines what to do. But as software started to come into the OT world and the internet came into the OT world, you started connecting these machines to business systems. You start connecting these machines to the internet. And now there's a huge overlap in the departments. And because they come from different worlds, because they have different goals, because they have different levels of priority, it's been hard to align those two groups so that they come together. Because really right now, OT can't do a lot in Industry 4.0 without taking advantage of IT. And IT won't really be able to transform, at least in manufacturing, the biggest part of the company, which is operations, without working with that team. So they need to find a way to work together so that they can leverage each other's knowledge and skill to use technology as a way to transform the business.
So when I think about, our customer base, we have a lot of large, complex manufacturers as customers. And when I go back to my old days of engineering, even though I left it, quite some time ago, but the PLC, programmable logic controllers, were already coming in. I worked at Honeywell. They had a huge division on various types of PLCs. So when I look at this IT OT overlap, even a couple of decades ago, what's happening because companies like SAP and others would come in for logistics and inventory management and WIP control and all the Kanban stuff that came in, the Lean and Six Sigma, and right. So you would bring in functional expertise, how to improve processes, which required redesign of the manufacturing floor layout, inventory control, because capital turnover was a huge issue in 2000s to make sure, right, everything now ships on sits on a boat somewhere. It's not on your balance sheet. So finance got really, really involved into manufacturing to get to lean manufacturing. So IT was working with OT at that time to provide or deployment like an application like SAP, right? Or there are a whole bunch of Sage and others where it came into about. So do you think that transition started around 20? Because I would think it started even before 2011. So was that 3.0 or 4.0 was fundamentally different? Like where did the shift happen from 3.0 to 4.0? Because IT, OT seemed like we're working together.
So none of the industrial revolutions are a set date and time and have an exact start and an exact end, because they've described eras that had profound changes on the industry and often then society as a result of it, including like how people work, how consumers buy. Like they changed society as a result of it. Industry 4.0 as a name, Industry 4.0, had a specific date that it was announced to the world, and it was a future-looking description of where we're going in the industry. So I don't know if there's a date that it started. It's just a fact that that's kind of when people started to use this as a visionary way of describing what's happening and where things are going in the industry. But we started to see that kind of bleeding into the new technologies over decades. And what's happening though is now there's becoming profound shifts as a result of it. Yes, of course, things like ERP went through a wave of starting with kind of the financial systems to be able to understand and manage how companies do their resource planning overall. And then as that started to kind of expand, they wanted to connect more to the actual function of operations so that they can collect more data and not just kind of give orders and put some basic information back into the system. And then you started to kind of expand more into this era of Industry 4.0, where you're taking advantage of kind of cyber physical systems and Internet of Things to generate an unprecedented amount of data at an operational level that companies are trying to figure out what to do with. And that's where, if you can bridge the departments together, that's where you make a huge impact in the company, not just limiting production data within production, supply chain data within supply chain, warehousing, quality, but uniting everything together as a company for a single source of truth where everything is pulling from the same spot that's all contextualized and understood. Now you could have marketing, you can have finance, you could have HR, you can have all sorts of functions pulling from the same data to allow companies to create new business models, new ways of providing value, new ways of capturing value, new ways of like organizing, new ways of working, just across the spectrum change in their companies.
About 6 months ago, I was flying back from Europe, and right next to me, there's a woman sitting. She was head of logistics of a major apparel brand. And so we were chatting because we had, 10 hours to kill. And she was coming back from a trip from Asia through Europe to San Francisco. And so we're talking about $5 t-shirt. There was in, PBS about 10 or 12 years ago. They talked about how they make these $5 t-shirt. And it was fascinating to listening to her. She said roughly when they push stuff out into retail, they have segmentation. What they drop in Europe may or may not be similar to what they drop in the US or Southeast Asia. But in roughly within a week, they got to gear up their logistics because they know from a pull-through wise what will sell in that season. So they may have, 120 items, but they figure out 11 of these will make money and people are buying. So they will flood their entire logistics with that request, and dynamically things will start shipping, right? And you think about that, and going back to the point that you just said, that unification of data, it's coming from marketing, from a demand, it's coming from point of sales, from an execution perspective. And you're telling, your clothing manufacturer in Vietnam or Philippines or Indonesia to put parts together from Egypt or somewhere else. That seems like for $5, $10, $20 product, an enormous amount of technology that's going in. So can you talk a little bit, because I want to spend time on this, a little more on this IT and OT, how you bring that organization together. How do you bring it together to execute so fast to hit certain price point, especially in this world when you say there's tariff today, there's no tariff tomorrow? What competence from a cultural perspective as a leadership team we should be looking at so that the agility that's required to execute that is actually there?
I wish there were a simple answer to this question. I think it depends a lot on what particular sub-vertical or industry you're in. It depends on your company's size, your company's maturity, your company's location, your company's culture. There's a lot of things that would help to determine that. In fact, there's been a couple of different assessment tools that are out there. SIRI is the most probably famous one out there, Smart Industry Readiness Index, which is a way of evaluating where you are in this Industry 4.0 journey kind of across the organization as a whole. Acatech is another one that has been out there to help you assess your current state so that everyone knows kind of what the end goal looks like, the art of the possible. What could you do if you adopted all technology everywhere? What would it kind of look like? And so this helps to guide you. Well, it really helps to assess you for where you're at. And then you use that to help determine what you should be investing in that would make the biggest impact for your company based off of all those criteria that I just mentioned. So there may be some that are low-hanging fruit, simple to adopt, with minor gains. There may be some that have huge gains, but are huge efforts required. And a lot of external factors can determine this. If you look at what happened, for example, during the pandemic, supply chain became immensely important. And a lot of companies started to adopt AI in demand forecasting and demand planning to be able to help do better prediction of what is going to come in and how they can deliver on time. That was driven by an external need. Some of it could be done by competitive pressure, change in consumer buying behaviors, so that an apparel manufacturer in this case may be able to better either meet customer needs or provide value in an entirely different way.
So I want to go back to this one point that you made that, these 3.0 to 4.0, even though they're like sort of markers in the press, but they're not revolutions that happen suddenly on a specific date. They're evolution that has been continuously happening. And so going back to the word that you just used, artificial intelligence, when I think about the manufacturing world I came to, or the customers that we have looked into, quantitative modeling, quantitative forecasting as a part of AI has been there for a long time, right? For inventory management, deploying a lot of these sort of Kanban or lean sort of principles. They were heavily statistically driven models that predicted what your demand is going to be, if weather is bad or weather is good, right? So that has been around. So when we think about in our imagination, so even though AI was there, like the way you said, industrial digitization was there, but with the ChatGPT launch, it came into the consumer mind, this generative AI, right? So when we think about AI, when you think about sort of where we are and where we're going, what do you see from inclusion of AI in both in IT and OT, from quant to language-based, or is there a separate world? Are there separate evolution that's happening in those two spheres?
Good question. So one of the things that makes AI unique is there's a couple things. One of them is the fact that it's one of very few technologies that I would argue will impact every person in every function, in every company, everywhere around the world. And there's very few outside of like the internet and electricity that have that big of a profound impact. The other part that makes artificial intelligence a little unique is artificial intelligence, you could argue, is more of a quest to replicate human intelligence than it is a particular technology. It's comprised of a lot of different technologies, a lot of different tools in a lot of different ways to replicate human intelligence. So artificial intelligence has been around, I would argue, for thousands of years. It's just only been turned into where we have tools available using computers and algorithms more recently, but still many, many decades. And then it's been refined with new stuff and new stuff coming out. Machine learning dominated this space for a very long period of time. And that kind of was an expansion off of a lot of statistics. And really, I would argue the main difference is statistics, you're getting a probability at the end for an outcome that you're looking for, but you're explicitly programming it what to do. Machine learning is a little different because you're not directly programming what you want it to do. You're not giving it the specific in order rules to follow. So this allows for more capabilities. But but machine learning has been used for at least a decade or more in manufacturing in many different functions. It could be to help with operations, help with finance, help with marketing, help with HR, everywhere. And I would argue operations has been one of the biggest benefits from it. I mean, this is an example where predictive maintenance has started to take off. This is where demand forecasting has been able to take off because of machine learning. Then in 2022, this thing ChatGPT came out and it completely changed the world. Now, GPTs weren't new because this was GPT 3.5 at the time. They had previous models before then, and large language models have existed before then. But to the average person, no one knew what they were. What ChatGPT did is it made it so that an average person could use it and understand its value. And now artificial intelligence became palpable to the average person. And so then a huge interest in all of artificial intelligence overall took off in late 2022. Even machine learning had a huge lift, even though there wasn't arguably much new there, but because everyone had an interest in ChatGPT and large language models and generative AI and everything in that space. And then even within the past couple of years, now we have AI agents and agentic AI, and who knows what's even going to be, kind of next after that. But now everyone is looking for ways of integrating artificial intelligence in any form into their processes, into their products, and even into the way that they service their customers. And so it's impacting every single department. Now, how IT and OT use it may be different, but they're both going to be using it. They're both going to be using all the different types, machine learning, generative AI, and agentic AI. They just may be using it for very different purposes.
So when you go back in the sort of the 1980s, and maybe it was 2.0, and you're an expert at this, so I'm not going to put a number on it. But when I think about 80s, my own experience in the U.S. manufacturing base, the floor was pretty sort of electromechanical. There's not a lot of electronics involved. And then this whole notion of PLCs were coming in. But lack of a better analogy, when I look at some of your posts, that Android posts that you have, it was more like putting a pacemaker on at a machine to maintain certain beats or certain things. They were more organ or machine specific. And then when I think about where Elon Musk is going with this Neuralink, which is implanting into your brain that your specific behavior and function. So you don't have to take Ozempic for obesity because your neural system is managed by mother of all AI in your brain, right? So when I go back to slapping these PLCs that were machine specific, then connecting the PLCs to get a rhythm in the line, and then connecting them to the ERP to get to a broader system evolution, right? So when you think, can you kind of walk us through that journey, this 3.0 to 4.0, and infusion of AI into the shop floor, but at a broader organization level, how it has happened and what is kind of happening now?
Sure. So yes, Industry 3.0 was really around kind of the PLC as like the core of the ability to help automate the manufacturing floor. And that was kind of like oversimplified the core. As we started to progress, kind of a couple things happened. One, newer technologies came out, like artificial intelligence, and I'm going to get to that one in a second. And the other is IoT, which is kind of a simplified way of doing connectivity. So now you had these machines and these PLCs kind of having a couple things happen. One, you added a software layer on top. So software started to now get into the IT space because you're having software on top of an electromechanical world for visibility, for control, just management. Then you have connectivity, which is driven by IoT to allow sensors, machines to communicate with each other and to potentially communicate with the outside world. And then when you add the software on top of that, now you have an unprecedented amount of data generation. And even according to IoT Analytics, as of last year, there's an estimated like 18.8 billion connected IoT devices that doesn't even include laptops and cell phones. And it's these devices that are creating this huge amount of data. And then the question becomes, what do you do with that data? And the first round more on analytics using machine learning can help with using it for evaluation, analysis, classification, but you could also use it for prediction. and the ability to go, all right, tell me what's going to happen based off of the history that I have. And then the beyond that, it's going to be kind of autonomous control, which is where agents come in to be able to self-optimize, learn, and actually tell machines what to do based off of kind of what's going on. So this is kind of, we're seeing this evolve and evolve and evolve over time. The Industry 4.0 label just kind of summarizes all of it and the time frame that kind of all this stuff is happening in. And we're seeing this happen right now. It doesn't mean every company is doing every one of these things, but collectively overall, our society is starting to do these things and take advantage of them. And the ones that don't start to do it, they're going to have a hard time competing in either now or next 10 years if they don't start to do this. I would view the IoT wave is more mature right now. We've been doing that for the past 10 years, connecting your assets down to a sensor, a machine, or your products in the field, connect to them so that you can collect data and you can control them. Now that we've done that, we're entering in kind of the next phase, which is what do I do now that I have this kind of connected empire of assets inside my building, assets outside my building, if they're products or serviceable devices, whatever they are. Now what do I do with them? And that's why I would argue the manufacturing area has such a capability to revolutionize, is because that function generates more data than anything else, because machines can pump out more data than humans. The question is just whether the companies are taking advantage of all that data that's being created so that they can either transform their operations or use it to sell the data, to create digital services. As an example here, if you're a company that builds machines, you can collect this data to help your internal processes, but you can also collect this data to sell back to customers to help them with their products or their manufacturing operations based off of likelihood for things to occur. So that enters into new business models, all by utilizing the same data as part of kind of your IoT infrastructure that you hopefully either have built or are building.
So Jeff, I'm going to take for our audience a couple of minutes to have you explain a specific concept of IoT. So I'm going to use an example, and correct me if I'm wrong, use your own example. So for example, if I'm making a device which has multiple parts in a highly automated, environment in a line, when that device comes off, I may have a little barcode on it. So from an inventory perspective, it goes through a little scanner and says device 1 made, device 2 made. I'm keeping track how many good devices came out. Now I may take 100 of those devices, put it on a pallet. The pallet may have a code, or pallet may have a sensor, because I'm moving that pallet out in my warehouse. So now I have an inventory of how many devices I've made and what pallet and what location it's stored. It gets on a truck, it gets on a boat. Now I know where it is. It gets into Walmart, the device is sold. I know what has been sold, right? So can you walk us through explaining, maybe that's a bad example, or give us a better example. How is IoT playing out above and beyond this PLC world that are coming out from, or still in, but very advanced and connected? But how does IoT play out exactly in a use case?
So we've been able to connect sensors or things that produce data to the thing that consumes it for a while. I would argue since the third industrial revolution. You could have just a very basic proximity sensor on a machine that's hardwired physically to a PLC that gives it a signal, I detect metal or I don't detect metal, as an example. What makes IoT a little bit different is you don't need to have a point communication from sensor to PLC and then PLC to system above it and system above it to system above that. IoT allows for kind of a one-to-many communication capability. It also has a requirement that there's some basic intelligence within the device itself so that it's aware of its own state and what it's doing, and it has its own communication capability to communicate to multiple things simultaneously. So you can get now I would say an IoT, if you want to call it, or a smart proximity sensor that isn't just having a hard 4 to 20 milliamp output going into a PLC, but is actually self-aware and can identify its state. I'm working, I'm not working. This is what's going on. Communicate that the signal is there or not. So now you can build up a whole network of these devices, and they allow for a tremendous more capability of gaining access to data, consuming that data, and allowing systems that do analysis to analyze the data. That's kind of, I would oversimplify what this IoT revolution is really about. But you can have barcode scanners, you can have any device that you can think of that can generate data can be an IoT device. And now they become honestly so cheap that people are just using them pretty much everywhere.
So what is this AI of things, the AIoT that we've been sort of hearing about? What are the concepts there? I know you talk about a lot there too.
I mean, in general, I would say that's still kind of more of a marketing term to describe the kind of I'd call it maybe the convergence of IoT and artificial intelligence, because at least in an industrial world, most artificial intelligence is used based off the data created by sensors, especially for machine learning. It's not as much for, your LLMs, your generative AI, or your agentic AI, but about machine learning. So if you're having sensors constantly pump out data, artificial intelligence is that layer that will allow that data to be used more than just whatever it was initially communicating with. So they're almost now always linked together. You're not doing one separately. If you're doing an artificial intelligence project within, I'm going to call it operations, it's most likely immediately connecting to hundreds, if not thousands of IoT devices. And so now it kind of became this AIoT initiative that companies are doing. So there's nothing really hard and fast behind it, except it's to say, boy, you're not really doing these separately anymore. You're not just doing connectivity for connectivity's sake. You're doing it to take advantage of it with artificial intelligence.
So I want to go to the other dimension of it, above and beyond operations, or including operations. There's a big piece called maintenance, right? Because these are complicated machines. They're mechanical parts, they're electrical parts. At times they wear out. They need to be tuned like a piano. So when I think about my personal experience, the most automated device that I have is my Tesla. That it's connected. It drives on its own most of the time, but it also has a maintenance schedule. That if there's something wrong, I get a text and a repair guy shows up and fixes it. So where is the maintenance world going with all these data that's now being available? Because uptime is a huge factor in gaining productivity in these highly automated factories where you're spending billions to invest. So how does maintenance play into this?
So I would say every single department within production, whether it's maintenance or in just operations, whether it's production, maintenance, quality, warehousing, logistics, whatever it is, they all can and will take advantage of AI, especially because of the data that's collected. One thing, this is more my opinion, is I would say is why has the maintenance function kind of taken off more and have much higher use and adoption of AI is because generally speaking, the function of maintenance is more consistent from manufacturer to manufacturer. So whether you make cheese or you make, cars, how you maintain is fairly similar. The equipment may be more complicated, the processes may be more complicated, but how you maintain the processes that you use, the data that you're collecting, and how you manage it is more consistent than, say, production, which is probably the most different, or even quality is still very different. So because of that, it became simpler to make more universal maintenance software to leverage artificial intelligence to do predictive maintenance from company to company. And that is part of the reason why I believe predictive maintenance has taken off more with the adoption of AI to be able to help identify when machines might fail based off of the historical records and kind of the information provided by the machine builders on the equipment.
So today, in general, I know possibly it's a too generic of a question. Do machines go down, or do people prevent those sort of through predictive maintenance most of the time?
Well, predictive maintenance isn't a solution to be used everywhere for everything. It's used for the places that it matters. And this is, if you start to do your kind of a maintenance evaluation, which assets you want to just run until they break and then you fix it reactively, which assets you want to do preventive maintenance, where you're doing planned, scheduled, checks, replacement of parts, lubrication, whatever it is. And then there's some that you want predictive maintenance on. Now, predictive maintenance, a little bit of it is hard to prove unless you have years of time, because if you prevent something, it's hard to ever say whether it did or didn't happen. You have to look at more statistically to go, hey, we on average, we're having to service this machine X number of times after doing predictive maintenance. Look, we're doing it less. It won't predict every single time of every single instance everywhere, but it will be able to start to give you leading indicators to let you know something is going wrong that your team might not have noticed, and you might want to take note of it. And you either can then choose to do many different things. You can do some preventative maintenance. You can just decide to let it run until it fails, but at least you're better informed and equipped to make those decisions.
So I want to come back to sort of the IT side of maintenance in a way. So you talked about the operations is no longer an island. It has many interconnected highways with the other functions and other parts of the sort of the creation and delivery process. So you also, in the early part of our discussion, you mentioned about governance, data governance, and most importantly, data security. Because when these PLCs were slapped onto a machine, they were not connected to anything. Unless someone actually went into a machine, sabotaged the machine, you didn't have to worry about security. Today, with all these state actors going after not only just stealing IPs, but attacking each other, that is one major vector to take things down, is take down operations. So when it comes to maintenance, traditionally in IT maintenance, where security and governance, like patch update and looking for vulnerability scans, all of those things have evolved into very, very sophisticated, processes. How does that overlay on the OT side today when you think about not just maintaining the machine, but maintaining the data infrastructure from a security and governance perspective?
So I'm not an expert on security or governance, but a big difference between IT and OT is the main priority. And that then impacts things like security. It impacts things on how the systems are maintained, because more for general IT, confidentiality is one of the biggest things that they do. Make sure that your data doesn't get out. We'll just oversimplify. OT, it's more about availability. My machine better not go down. That right there creates very different incentives for how systems are set up, how they're managed, how they're secure, because they have different kind of fundamental operating objectives with it. So in the past few years, ISA helped to create a new set of standards specifically for industrial control systems that then later got adopted by IEC. It's IEC 62443 to help lay out how to do security properly for the control systems, the stuff that's actually, telling the machines what to do and how to work, so that they can attempt to start to bridge with IT. And how do we govern, how do we secure these systems so that we're both happy?
So I want to move into the other S word, not just security, is smart. So you have talked a lot about sort of smart manufacturing. You've created a framework around modernize, optimize, transform. Can you kind of walk us through what is, where is all these technology, all these connectivity, all these intelligence sort of evolving into this framework that you have?
So I hear all the time, we're doing Industry 4.0 projects, or we're in the middle of our digital transformation. It's great. That's an exciting title to be able to say that. But what does it actually mean when someone says that? And too often when I lift up the hood on these so-called transformation projects, they're really just modernizing or optimizing. Now, both are necessary, but neither is transformation, and neither matches the full vision of Industry 4.0. So there are different ways I like to describe the types of projects related to Industry 4.0. You have your modernization projects, your optimization projects, and your transformation projects. So modernizing is about replacing old systems and bringing operations up to kind of modern standards. Think about replacing an outdated ERP system, or upgrading your network infrastructure, or moving from paper-based processes to digital ones. This is your foundation. It's connecting systems, digitizing information, and kind of creating a new baseline for what comes next. Optimizing is about getting the most out of what you already have. ideally done after modernization, but doesn't have to be. And this is where you configure, you tweak, you fine tune processes, sometimes using new technology like artificial intelligence to make what you already do faster, more efficient, higher quality, more consistent, whatever the goal is. It's improvement within your existing model. Transformation is where you fundamentally change your company, how it operates, how it provides or captures value, or even how employees work. And it's a huge leap where technology isn't a bolt-on project like it would be potentially for optimization, but it becomes the operating system of your business. Now, the reason these distinctions really matter is, I would argue, because they're graded differently, or at least they should be. And when you attempt to grade them all the same is when you start to have project failures. Because modernizing doesn't usually create big headline grabbing value on its own. It's really about enabling value for what comes next. Upgrading an ERP or modernizing your network or moving from paper to digital might not spike your revenue tomorrow, but they lay the groundwork for future optimization. KPIs here should include things like system performance uplift or failure rate reduction or lower support and maintenance costs and faster time to deploy for future initiatives. Optimization is the easiest one to measure because it's a before and after, directly tied to a process being improved. Cycle time, scrap rate, yield labor efficiency. You can see the impact quickly and clearly. Now, transformation is tricky because by definition, you're changing into something new, so you often don't have a baseline to measure against. And instead, you might look at adoption rates or customer engagement or longer-term business outcomes like market share expansion and revenue growth. And look, these aren't always neat, separate projects. Sometimes you modernize and optimize together, or you transform while modernizing. The point is, know what type of project that you're doing and grade it appropriately. So right now, if I would say a big thing to note here, though, is that the primary transformation people are talking about and have been doing for the past decade is digital transformation. But I would argue what's the next big major revolution is intelligence transformation. Because once digital transformation has connected your infrastructure, digitized your processes, unified your data, and established one source of truth and for visibility and control, the next step becomes autonomy. And this is where processes become self-optimizing and self-configuring, adaptive and learning. And autonomous decision-making isn't a dashboard. It's kind of embedded directly into your processes themselves. And this is when manufacturers evolve from being connected to like truly self-driving manufacturers.
So I want to go back to a simple example and maybe end our conversation on that. Recently I saw a YouTube documentary. A European sneaker manufacturer is building the entire sneaker in sort of a 3D printed model, and that can bring in a complete different level of performance that you can't go manufacture the old way. The sole is manufactured and the top is put together and etc., right? Even though that part is automated. So going back to your difference between optimizing and transforming, is if I move from a traditional manufacturing where I'm trying to, as you said, increase yield, reduce my scrap rate and etc., for the old school manufacturer that they manufacture sneakers, am I hearing from you that is optimization? But if I move to a complete different design for manufacturing process because the product outcome is different, I'm trying to attain a different product, that is transformation? Or can you give us a physical example of that?
I mean, it can be. And like I said, sometimes these are combined. So I often see a lot of projects where you're replacing or modernizing a system as a good example, especially an older legacy software system or a way of doing things with a newer one where they have no plans of evaluating how they're actually going to improve the business. They just know that they have to because of it could be anything from the software is not going to be supported, it's end of life, or something is costing them a lot of money from a maintenance or servicing of that. And so the justification is quite different, like I was saying there. But optimizing, a lot of times if you're good, you're modernizing and optimizing at the same time. Those are kind of done together. Hey, we want to replace our our MES. We want to replace our ERP, and we want to replace our maintenance system, and not just modernize it, but optimize it while doing it. Make our processes better, more efficient, like I said, faster, whatever they are. And you're kind of doing those simultaneously. But a transformation may completely uproot everything you're doing. At that level, you're more questioning things like, why are we even doing it this way? Is there an entirely different or better way to, let's just say, manufacture at a broad level? Or it could be to take advantage of what we're doing to provide new value to our customers. And like I said, you don't have to have a very fine line between them, but you need to think about them that way so you can approach them the right way. Because if you look at a lot of major studies that are out there, there's a famous one from McKinsey that, gosh, is like 8 years old now that said like 70% of digital transformations fail. There's been multiple studies since then that have the numbers between the 60 and 80%, all saying the same thing, that digital transformation projects fail. But KPMG came out with a study a couple of years ago that actually said 99% of digital transformation initiatives returned at least a 1% ROI. So how can you have these two very opposing things? Transformations fail. Almost every one is generating more money back than what we put in. It's because they're not, I would argue, not being graded the right way. They may have missed their goals, but it still was worth the money. And so it's a way of thinking about the projects the right way. Sometimes digital transformation projects are too lofty, or you're, like I said, you're thinking about it the wrong way, which means you're assigning the wrong team to it. You're grading the wrong way. Even though it returned an ROI, it didn't do what you wanted it to do. And so that's why when I start with these things, I recommend, because companies usually have hundreds of simultaneous projects going on. And one of the things I like to do is start to categorize them into which ones are modernizing, optimizing, and transforming. I mean, there's other models you can follow if you want, like the Gartner model that kind of goes over, running the business, improving the business, and growing the business. It's a very similar concept.
So I have one last question. I know we're running over our time, but because you brought up money maketh market. So I'm going to ask you one question about like what we saw, my own experience. I worked in aerospace a long time ago in Honeywell, and I saw how GE Capital transformed airline industry by owning the equipment, paying for it. So they had as much say to Boeing and McDonnell Douglas at that time, or anybody else, as United and others had, right? Because they financed, they owned. Do you see at financial transformation playing in broader these transformation plays where different financing model coming in, enabling so-called manufacturers to, deploy capital in a different model?
Absolutely. I mean, absolutely. I would say this industry is maybe behind some other industries, and maybe the tech industry started with it. But to go from selling licenses of software to subscription and then software as a service dramatically changed the way that consumers buy just across the world, let alone within manufacturing. And you're starting to see the same thing within the manufacturing world. And I would argue there's kind of like three things that are starting to take shape and grow at different speeds. The first one is manufacturers kind of migrating away from selling physical goods and stuff to increasing their revenue through digital services, through software and data insights. In fact, if you were to go look at big fairs like Hannover Messe in Germany, you'll find that most manufacturers are demonstrating what they do, and their go-to-market is represented through one of those three. Whether they directly make the software, they partner with the software company, but they're consuming more revenue through these additional measures of, like I said, software, data insights, or digital services that are overlaid on top of their existing install base. The second is switching to subscription models or as a service models, where now you're setting up more regular reoccurring revenue. I mean, there's an entire report that has been, that was produced by IoT Analytics on equipment as a service and where that industry is going for machine builders to, instead of selling machine, they're selling a service through their machine. I mean, if you look at major companies out there, Philips now offers light as a service. ThyssenKrupp offers material as a service. Michelin, I think, offers tire as a service. Like, there's a whole bunch of companies that are offering as a service models that are out there. And then the last is outcome-based contracts. This is where you you charge for the outcome delivered instead of the asset or the service. And if you go to that route, you completely change how your entire company works because you're on the hook for the outcome delivered rather than the thing that you're actually selling or providing. So we're seeing kind of an advancement in kind of all of those, but most of them in the first one, which is digital services, the data insights, and the software.
Amazing. I don't know why the hour flew by. Jeff, I got to have you back. There were so many deep dives I wanted to take, but you're absolutely brilliant. Thank you for being here. I know our audience is going to love it. Peter is going to follow up for additional sessions. We'd love to have you back. Thank you.
Sounds good. Thanks for having me.